Hello students, this is your first video lecture on the chapter magnetic properties of materials. Okay, so today we shall discuss magnetic properties of different types of materials. On the basis of how the materials respond to external magnetic field, we have divided the materials into three categories. Those are number one, diamagnetic, number two, paramagnetic, number three, ferromagnetic. First of all, these classifications are based upon the values of chi. What is chi? Chi is nothing but the magnetic susceptibility. What is magnetic susceptibility first? 1 second. Magnetic susceptibility, in the previous topic we have already discussed that it is a measure that how a material responds to external magnetic field. Okay, so it is denoted as chi. Okay, so every material will have its own chi value. It is not x, it looks like almost x, but like this. Okay, this is the actual notation. This is chi. Now chi value, if it is in between minus 1 to 0, that means if it is always negative but very small value of small negative value, then it comes under diamagnetic substance. If chi is greater than 0 but less than a small positive number, then it is called paramagnetic. For this ferromagnetic, it is very greater than 1. It is a very large value. Okay. Now from this we can go on like this. The relation between chi and relative permeability. What is that? Suppose I will add 1 with chi. Okay, so if you add 1 here, it will become like chi plus 1. You have to also add 1 here also. If you add 1 here, it will become 1. If you add 1 here, it will become 0. Now similarly, here I am not writing again chi plus 1 because chi plus 1 is mu r. So I will directly write here mu r. Mu r, that is relative permeability. I will also replace this value with mu r, but for your demonstration I am writing here chi plus 1. Now if 1 is added here it will be also 1 plus 1, so it will be epsilon plus 1. Here it is between 1 to epsilon plus 1. Here already you have got. Now come to this one also. If you add 1 here, there is no difference because chi already is a very large number. So if you add 1 up there, there is no difference in the value, but still you have to write here mu r is very greater than 1. Now I can replace this now as mu r also, mu r. Okay. Now from this I also can calculate what is the mu value. Mu is magnetic permeability. Like in electrostatics you studied that relative permittivity like this, it was epsilon was permittivity simply, epsilon r was relative permittivity, okay, epsilon naught was permittivity of free space, like this. In magnetism also there are mu naught, mu r, mu naught is permeability of free space, mu r is relative permittivity of any medium, and another thing is mu is permeability of a medium. So what is the relationship? Now we shall see. You multiply mu naught everywhere. If you multiply mu naught here, it will become mu r mu naught. Here if you multiply mu naught here, it will be mu naught. Here it is 0. So 0. Here similarly, if you multiply mu naught, if you multiply mu naught here, it will be mu r mu naught. If you multiply here mu naught, here it is almost it is greater than 1, of course. So just multiply it. Okay, no problem. Just multiply here mu naught epsilon plus 1. Okay. Now here also mu naught mu r greater than mu naught. Very simple. Here in the next step it will become what? 0 less than mu r mu naught is nothing but mu itself, and this is mu naught. In this case mu naught is less than mu and less than this value. Okay, but from both these conditions I can conclude that mu is less than, one second, sorry for the interruption. Okay, from this I can conclude that okay, there is one okay, I can replace this 0. Okay, no problem, 0 is no. So this is the conclusion, mu is less than mu naught. Okay, I was here. Now here it is greater than mu naught, but if something is multiplied with mu naught, then it is less than mu naught. That means conclusion is mu naught is less than mu. This is the conclusion. Now the third conclusion will be mu is very greater than mu naught. This is the third conclusion. Okay. So this is all about classifications, how these materials are classified. So first we shall go through the first type, that is diamagnetic substance. So first type is our diamagnetic substance. Of course, a material that is repelled by external magnetic field is called a diamagnetic substance because its chi value is negative. Chi is magnetic susceptibility. It is negative means this material is totally averse or it is reluctant to accept any magnetic field. So how it is? Now suppose this is a material and we are applying magnetic field here. these are external magnetic field lines, and this material is diamagnetic in the sense, why it is diamagnetic? Inside the material you must be knowing that the atoms have new electrons, and those electrons are spinning in some fashion, clockwise or anti-clockwise, whatever. Because of their spinning, they are creating currents or producing currents, because electron itself is a charged body and it is moving means it is producing current. Because of that circulating current, magnetic field is produced. If magnetic field is produced, then we can simply say a loop current is creating a magnetic moment, because we do know that a magnetic dipole moment is nothing but a circulating current. So electron is circulating means it is producing a circulating current, and it acts as a magnetic dipole moment, which has some magnetic dipole moment value. Now in this case, what happens, if external magnetic field is applied, always there are two types of electrons, those who rotate clockwise and others those who rotate counterclockwise, and likewise they produce two types of dipole moments. What are those dipole moments? Suppose one is rotating like this, so its magnetic field will be towards the board, that means it will be like this. And if the electron is revolving like this, its magnetic field will be out of the board. That means one is either in that direction or another is in that direction. That means two directions. In diamagnetic substance, what happens, if external magnetic field is applied, then immediately the electrons, those have magnetic moments in this particular direction, slow down. I am repeating, the electrons, those are producing the magnetic moment in this direction particularly, they slow down. If they slow down, their current decreases. If their current decreases, magnetic moment also decreases. That means the magnetic moment in this direction inside the material becomes weaker. Okay. Now the electrons rotating, producing magnetic moments in this direction are speed up. They get speed up. They increase their speed. So if the speed increases, then current also increases. If current increases, then magnetic moment also increases. That means in this direction magnetic moments get increased. If magnetic moments get increased, then they will repel the external magnetic field or not. That means the net magnetic moment inside the material is in this manner. So they are repelling the external fields. So external field has nothing to do. They will simply avoid the material and go like this. Very simple, because they are repelling. But this middle line has no other options. It has to penetrate through the material, but this is the only line that passes through the material. It is bound to pass through that. Otherwise, these two, all other lines will get deflected like this. And this is the result of repulsion between the magnetic material and magnetic field. Okay, this is the way how a diamagnetic substance responds to external magnetic field. Okay, now we shall go through some examples. Examples are bismuth. It is a typical diamagnetic substance. Then copper. Okay, nitrogen, water, sodium chloride, your normal salt. Okay, these are typical diamagnetic substances. Another thing here is the most not common but the most eligible in this category is our superconductors. Let me erase it. Superconductors. These are the best diamagnetic substances available. That means they have the ideal values, that is chi is equal to -1 or mu r is equal to 0. This is the typical magnetic property of superconductors. Then question is, what is a superconductor? First of all, superconductors, one thing you must be remembering that if in a substance, typically in a metal or a conductor, if you increase the temperature, its resistance value decreases. Increases. If inside a conductor or metal, if you increase the temperature, its resistance increases. That means it loses its conductivity value to some extent. But here we are doing the opposite thing, that is, we are decreasing the temperature. If you decrease the temperature, its conductivity increases. It is already a conductor, but still its conductivity is increasing if you decrease the temperature. If you decrease the temperature continuously at some particular temperature below which it will become a superconductor. Okay, that means its resistance is completely zero. And moreover, these superconductors also show diamagnetic property, and that is the ideal diamagnetic property that I just said you. Now, one more thing. When superconductors show it is called perfect diamagnetism. Perfect diamagnetism. This phenomenon is called Misner effect. This is called Misner effect. That is the phenomenon by which the superconductors also show the perfect diamagnetism property is called Misner effect. Okay. Another thing is where these superconductors are used. These are normally used in case of your braking system in very fast trains like bullet trains. These are finding their applications in bullet trains braking system. Okay, these are you all are aware with these bullet trains. Okay, so this is all about from this class. In the next class we shall discuss paramagnetic substances, okay, or paramagnetism. Thank you.